We're in Organic Chemistry 2310, and we will be talking about alkenes today. An alkene has a carbon-carbon double bond, and there are three types: terminal, internal, and cycloalkene. The terminal alkene has the double bond at the end of the chain, internal has the double bond in the middle of the chain, and cycloalkene has the double bond in a cyclic compound. One thing that's different between alkenes and alkanes are that the pi bond is much weaker than the sigma bond, so therefore the pi bond is reactive and alkenes can undergo reactions that alkanes can't. Properties of the double bond are that rotation is restricted, 2 diastereomers are possible, cis and trans, located here and here, and stability increases as the number of R groups increase by movement of electron density, and here's the general trend. Properties of alkenes are that they have low melting and boiling points and that they are soluble in organic solvents but not soluble in water. To make an alkene, you can do a dehydrohalogenation reaction, and that takes a nucleophile to deprotonate a hydrogen, forming a double bond and kicking on a leaving group. A dehydration reaction is a type of elimination reaction. Your alcohol is made to a better leaving group by a proton, and then a base attacks a hydrogen, which makes an alkene, which kicks off your water, forming your double bond. Addition reactions with alkenes that we will be talking about today include hydrohalogenation, hydration, halogenation, halohydrin formation, and hydroboration oxidation. And this is the general setup for an addition reaction.
So the first addition reaction we're going to talk about is hydrohalogenation. That's when a halogen and a hydrogen attack an alkene to form a new compound. So the first step is to break the pi bond here. And you break that bond, and you break the bond between the hydrogen and halogen. The pi bond attacks the hydrogen and forms the carbocation over here. Then from there, the halogen, in this case bromine, comes to attack the carbocation. You come down here, and a new compound is formed. So to remember, Markovnikov's rule is that the hydrogen from the compound up here binds to the least substituted carbon because it forms the most stable carbocation. Here is hydration. This is the addition of water to form an alcohol. So you start here with a double bond, which attacks the hydrogen on an H3O+. Come down here, and it forms a carbocation. The oxygen from this water over here attacks the carbocation and attaches. This makes a positive charge here, so to neutralize this compound, again another base, in this case water, comes here, attacks the hydrogen, and then over here you're left with an OH group, the H from the original, and another H3. There's a halogenation reaction, which is the addition of 2 halogens, usually in this X2 formation. So the first step here is to break the pi bond between the 2 carbons, so that the pi bond comes up and attacks one of the halogens, and then on the same halogen a lone pair comes down and attacks here, forming this bridged polonium ion. From there, the other halogen from the original over here comes up and backside attacks one of the carbons, popping off one of these bonds here, and forming this transformation right here with one halogen on top and one on the bottom.
Is a halohydrin reaction, which is the addition of a halogen and the formation of an alcohol from an alkene. So the first step to this mechanism is the formation of the halonium ion. This double bond attacks the halogen here and forms the bridged halonium ion. This bromine in solution is surrounded by the water, and therefore the water attacks as the nucleophile, forming the trans isomer via anti-addition. The next step is the base, which in this case is water, is going to deprotonate this water, and it forms the trans isomer with the alcohol and the bromine on the alkene. Hydroboration oxidation reaction, which is a 2-step conversion of an alkene to an alcohol. The first step is the syn addition of BH2 and hydrogen, where hydrogen is attacking the more substituted carbon with anti-Markovnikov's rule. The double bond then attacks a partially charged boron, forming this transition state. Right here we have the syn addition of that hydrogen and that BH2. And the final step is the oxidation reaction, where an OH replaces the BH2 and forms the same configuration as before.